All right, Precalc, moving into Chapter 8, Lesson 5, we're working on counting principles. Our essential question says, how do you count the number of ways in which an event can occur? So this is working with different counting principles, and you kind of started this in elementary school. So obviously it's going to get a little harder, a little quicker. So let's look what they have to say. 8 pieces of paper are numbered. Sorry, I write that funny. 1 through 8 and placed in a box. 1 piece is drawn from the box. The number is written down, and the piece of paper is returned to the box. So obviously this is super important that that is written there. Then a second piece of paper is drawn, the number is written down, and guess what? That one is returned to the box. Finally, the two numbers are added together, and how many different, keyword different, ways can a sum of 12 be obtained? Well, between the numbers 1 through 8, how many different ways can I obtain the number 12? So we have 1 through 8. I can't have 1 in anything. 2 and 10, 10's not there. 3 and 9, 9's not there. So let's start with 4. I know that 4 plus 8 can give me a sum of 12. I know 5 plus 7 can give me a sum of 12. 6 plus 6, we can have this one because they told us that they were returned to the box. So if it wasn't returned to the box, 6 plus 6 could not occur. And we can have these backwards because I could choose a 7 first and then a 5. And I could choose an 8 first and then a 4. So notice there are 5 different ways in which a sum of 12 can be obtained. All right, let's look at number 2. Determine how many ways a computer can randomly generate 2 integers from 1 to 12 whose sum is 6. So we have to do the same thing. Now we have numbers 1 through 12, and I have to find a sum of 6. So 1 plus 5 will give me a sum of 6. And this is a computer. It doesn't talk about like papers going back in. So we have to think, can we get 2 plus 4 for sure? Can we get 3 plus 3? Yes. And because it's just a computer that's generating 2 random numbers, we can also have 4 plus 2 and 5 plus 1. So there are 1, 2, 3, 4, 5 ways in which a computer can randomly generate 2 integers. All right, example 3. Determine in how many ways a computer can randomly generate 2 distinct. So now we need to know what distinct means, integers from 1 to 12, whose sum is 10. So now we're looking for things that add up to be 10. We know we have numbers 1 through 12. We want the sum to be 10. Can we get 1 and 9? Yes. Can we get 2 and 8? For sure. 3 and 7. 4 and 6. Can we do 5 and 5 if we need distinct integers? No, we can't do that. Can we do 6 and 4? Yes, we can, because they're still different integers. They're just picked a different way. 7 and 3? Yes. 8 and 2? Yes. 9 and 1? Yes. So 1, 2, 3, 4, 5, 6, 7, 8 different ways in which this can happen. All right, moving on to the next question. A combination lock will open when the right choice of 3 numbers, 1 through 30. So the first thing we have to look at is we have 1 to 30 numbers. That's a lot of numbers for a combination lock. Is selected. How many different lock combinations are possible? So notice it has to have 3 numbers, and we have to talk about what numbers can go in the first slot, the second slot, and the third slot. So in the first slot, I can have 30 different numbers, 1 to 30. Can I have the same in the second slot? I can. I can have 30 different numbers. And notice that third slot, I can also have 30 different numbers. It didn't say they have to be distinct or different numbers. So now the big question is, what do I do with all these numbers? I am going to multiply 30 times 30 times 30, and 30 times 30 times 30 gives us 27,000. All right, we're gonna do a couple more here. They're gonna get really fun. In a certain state, each automobile license plate number consists of 2 letters. Okay, well, I'm gonna put the letters in green. 2 letters followed by a 4-digit number. Well, how many digits? We know we have to have 4 numbers. How many digits are there? There's only 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 different digits. So I know that there are 10 different digits that we can have for the last 4 spaces. And we have to know how many letters we have, because it says that it consists of 2 letters. Well, that's going to be 26 times 26. And notice we're always going to multiply all this. When I multiply 26 times 26 times 10, 10, 10, 10, I do get an answer of 6,760,000 different ways. The last thing we're going to talk about is the difference between permutations and combinations. Okay, so we did work with the counting principle, and we're going to continue permutations in the second half of this video. So I do want you to look at a permutation. Permutations. A permutation of n different elements is an ordering of the elements such that one element is first, second, third, and so on. And the formula here is n times n minus 1 factorial. Now let's talk about it. In a horse race, there is one horse that comes in first, one that comes in second, and one that comes in third. And order matters here because remember, that first place horse didn't come to make third place. So remember, in permutations, order matters. So let's look at one in which order matters. How many ways can 8 children line up in a row? Well, obviously, there's 8 children, 2, 3, 4, 5, 6, 7, 8. In the first spot, everybody wants to be the engineer, the top of the choo-choo train. So in the first place, there can be 8 children. In the second place, that 1 is already taken, so there can only be 7. Now 2 have been taken, so 6. 3 have been taken, so 5, and you get the point. 4, 3, 2, 1. Where have you seen this? Good. You have seen this in our factorial. So remember that this is just 8 factorial, and the answer to 8 factorial is there are 40,320 different ways in which these children can line up in a row. Watch my next video to learn more about permutations and more about permutations versus combinations.